जय जगन्नाथ पिला माने आज लेक्चर को समस्त को स्वागत। आज लेक्चर रे हमें बहुत सारा क्वेश्चन प्रैक्टिस करबा। लास्ट लेक्चर रे हमें जेमिति क्वेश्चन प्रैक्टिस करूतले तो ताको हमें कंटिन्यू करबा। तो लास्ट लेक्चर रे तुम मानको मु क्वेश्चन प्रैक्टिस करौतले आ सेठी हमें जस्ट गोटे सिंबल रे कंफ्यूजन होतले तो सेटा हमें फर्स्ट क्लैरिफाई करबा। फर्स्ट हमें देखिबा डिटेल तार स्टेटमेंट कोन अछि तापर आगु बढ़िबा। ठीक अछि। बर्तमान देखो हमें लास्ट लेक्चर रे बर्तमान ए जो प्रॉब्लम आम करूले। ठीक अच्छे। यही प्रॉब्लम रो देखो ये कौन अच्छी प्रथम ये हम पाखे एस ये जो साइन अच्छी दीटा सेट भितर ये साइन अच्छी आम साधारणतः कन्फ्यूज हो जाती। देखो ये जो साइन आउ एस सबसेट ऑफ टी ये जो दीटा साइन रहा ये दीटा साइन भितर बहुत सारा डिफरेंस अच्छी। ठीक अच्छे। बहुत सारा डिफरेंस ये कौन डिनोट करूची तुमको मो लास्ट लेक्चर रे कहथिले जहा जेमिति कहथिले सेटा परफेक्ट थिला। किंतु एठी जो स्टेटमेंट अछि ए स्टेटमेंट अनुसार ए जो सिंबल रे मीनिंग होची सबसेट तो एठी टिके प्रिंटिंग मिस्टेक हेची आको हम सबसेट करनवा आ सबसेट कर देले हमर स्टेटमेंट जहा थिला स्टेटमेंट हमर पूरा करेक्ट हेजिबो। बुझला काहे कि ना एठी दीटा सेट भितर हम कथा कहउचंदी तो एई दीटार मीनिंग कोन हमें बुझिबा। वर्तमान जतेला हम एमिति लिखुचंदी एस लेस और इक्वल टू टी तो ता माने कोन ना आम पाखे गोटे सेट एस अच्छी आम पाखे गोटे सेट टी अच्छी तो आमे जदि एमती लिखिबा टी रो सबु एलिमेंट एस ठू बड़ बा एस रो सबु एलिमेंट टी रो सबु एलिमेंट ठू सान। बुझिला कि नहीं ईच एंड एवरी एलिमेंट ऑफ टी इज बिगर देन द एलिमेंट ऑफ एस ईच एंड एवरी एलिमेंट ऑफ एस। बुझिला कि नहीं ता माने कोन मु जदि एस को पिक करूची एस इज इक्वल टू 1 2 3 4 ठीक अच्छे ताले टी को मु कौन चूज करी सो दैट मोर ए जो डेफिनेशन अच्छी बा ए जो प्रॉपर्टी अच्छी बा जो हमको एक्सप्रेशन दिया से एक्सप्रेशन टा ट्रू हेजिबो। ईच एंड एवरी एलिमेंट टी रो एस ठू बड़ हबो नले ता सहित इक्वल हेई परिबो तो आमे एमिति पिक करि परिबा 3 4 6 7 एई भले आमे पिक करि परिबो। बुझिला कि नहीं किंतु आमे एमिति का पिक करि परिबा नाही कि आमे एठी -1 2 -6 7 एई भले आमे चूज करि परिबा नाही। तो एइटार मीनिंग कोन कहउची ईच एंड एवरी एलिमेंट ऑफ टी इज बिगर देन एस ईच एंड एवरी एलिमेंट ऑफ एस। किंतु आमे जतबेले सबसेट कहउचंदी सबसेट र मीनिंग कोन ईच एंड एवरी एलिमेंट ऑफ एस इज एन एलिमेंट ऑफ टी एस रो सबु एलिमेंट गुडा टी रो गोटे मेंबर हबो। बुझिला कि नहीं ईच एंड एवरी एलिमेंट किंतु एठी देखो मु 1 2 को टी भितरे मु कंसीडर करि नै टी भितरे मु पिक करि नै। बुझिला कि नहीं ताले मु जतेबेले एस एठी पिक करबी एस इज इक्वल टू 1 2 3 4 ताले टी को कौन पिक करबी टी इज इक्वल टू मु पिक करी देखो ईच एंड एवरी एलिमेंट ऑफ एस ताले एस रो सब एलिमेंट को मु आगे पिक करी तापर एक्स्ट्रा एलिमेंट मु किछि टी रे ऐड करी ताले एमिति हेले ही एस सबसेट ऑफ टी हबो। तो लास्ट लेक्चर हमें जतेबेले एठी हमें पढिथिले फर्स्ट हमर जो प्रॉब्लम थिला फर्स्ट प्रॉब्लम टा कोन थिला तो आमे फर्स्ट प्रॉब्लम टा को कौन मानिक चलतिले एस इज लेस और इक्वल टू टी ए अनुसार तमन को मु जो एक्सप्लेनेशन देइथिले से एक्सप्लेनेशन टा पूरा जस्टिफाई थिला। ठीक अछि किंतु एबे देखिबा जदी हमरो एठी वर्तमान लेस और इक्वल टू न थाई कि हम पाखर जदी सबसेट और इक्वल टू अछि ताहाले हमें कोबला डील करबा। बुझले कि नहीं जदी सबसेट और इक्वल टू अछि हमें कोबला डील करबा सेटा को देखिबा। ठीक अछि देखो हम पाखर कोन अछि एस सबसेट और इक्वल टू टी फास्ट हमें कौन करिबा हमको फास्ट स्टेटमेंट कौन दिया छी लेट एस एंड टी बी टू सबसेट्स ऑफ रियल नंबर एस एंड टी दिटा रियल नंबर ऑफ सबसेट अछंती एंड द अदर प्रॉपर्टी इज एस इज सबसेट ऑफ बी एंड एस इज नॉन एम्प्टी टी ऊपर हम पाखरे कोनोसी कोन कंडीशन नै किंतु देखो जदी हमको एस टा नॉन एम्प्टी दे देला ताले बाय डिफॉल्ट टी भी कोन हेजिवो नॉन एम्प्टी हेजिवो काहे एस रो सब एलिमेंट टी रे आसीबो। बुझले कि नहीं तो आउ थोरे हमें टी को नॉन एम्प्टी देखिबारे कोनोसी दरकार नहीं किसी दरकार नहीं कि हमें पुणी लिखियो टी इज नॉन एम्प्टी हम जदि एस को नॉन एम्प्टी लिखि दोछन ताले बाय डिफॉल्ट टी भी नॉन एम्प्टी आइजो काहे कि ना प्रॉपर्टी देछि एस इज सबसेट और इक्वल टू टी। बुझिला कि नहीं क्लियर हे गेलो देन तापर कोन कहै देखो देन प्रूव दैट इफ टी इज बाउंडेड अबव देन सुप्रीमम ऑफ सेट एस इज लेस और इक्वल टू और स्मॉलर देन द सुप्रीमम ऑफ टी। बुझिला कि नहीं ताले हमें स्टार्ट कोन करबा ए जो सुप्रीमम ऑफ सेट टी अछि ताको हमें पिक कर दवा लेट सुप्रीमम ऑफ टी इज इक्वल टू के then the definition of supremum what is the definition of supremum if k is the supremum then each and every element of t is less than or equal to k yes or no if k is my supremum then each and every element of y is smaller than or equal to k by the definition we can write this expression okay since S is a subset or equal to T, since S is a subset or equal to T, then each and every element of S is an element of T. If X belongs to S, then this implies that X is also belongs to T. Yes or no? Next, so X is smaller than K. Yes or no? देखो बर्तमान एउटे मोर एस रे एलिमेंट रहिला तापर आ किछटा एलिमेंट मु ऐड कर देले देखो एउटे मोर एस रे एलिमेंट ए टोटलटा होची टी रो एलिमेंट एठी रहिला मोर के ए टी रो सब एलिमेंट उडा के ठू लेस ताला हम एठी कोन कहि परिबा ए जो एस रो मेंबर उडा रहिले एठी एस रो मेंबर अछि ताले एस रो मेंबर इज आल्सो लेस और इक्वल टू के. यस और नो? तो सेही जिंसटा हम लिखले सो के इज बिगर देन और इक्वल टू एक्स, एक्स बिलोंग्स टू एस, showing that K is also a upper bound of S. K is also a upper bound. Hence, আমি এটি কোন লিখি পারিবা? Hence, supremum of S. তাহলে যদি এইটি দেখো এই যে x টা মু নেলি, x is an element of S, then x is also less or equal to K. তাহলে যে S সেট র সুপ্রিমম আসিবো, তাহলে সুপ্রিমম টা আইদর K সহিত ইকুয়াল হবো নহলে K ठू लेस हबो. ताले देखो एठी जो मैं S सेट को रखिली ए जो S सेट टा S सेट रो जहां भी एलिमेंट अछि सब K ठू लेस अछंती. बुझिला कि नहीं? ताले ए जो सुप्रीमम टा आइदर K से तो इक्वल हबो नहले कोन हबो K ठू लेस हबो. बुझि परछो कि नहीं? ताले एठी हमको लिखले सुप्रीमम ऑफ S इज लेस और इक्वल टू K. K कोन थिला? K इज सुप्रीमम ऑफ T. ताले हम एठी कोन प्रूव कर देले? सुप्रीमम ऑफ S इज लेस और इक्वल टू सुप्रीमम ऑफ T एज K इज इक्वल टू सुप्रीमम ऑफ T. बुझिला कि नहीं? एबे हम देखिबा इनफिमम केस रे कोन अछि हम पाखरे स्टेटमेंट. बुझिला? लास्ट लेक्चर में कंफ्यूज होउतिले केवल ए सिंबल पई. एठी एक्चुअली सेटा कोन सबसेट और इक्वल टू. बुझिला कि नहीं? तो सबसेट और इक्वल टू हेले हमर ए जो क्वेश्चन टा फ्रेम करा आइछ तो सेटा हमें ठीक से बुझि परिबा. यस और नो? एबे जीवा देखो नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन हम कोन कहिछि कि इफ T is bounded below, if T is bounded below, then infimum of T is less or equal to infimum of S. बुझला कि नहीं? ताल देखो एठी वर्तमान हम पाखरे S रो एलिमेंट रहिले आउ किछि एलिमेंट T रो अछि एपटे भी थाई पारे. बुझला कि नहीं? एठी भी एपटे भी थाई पारे. मु वर्तमान S रो एलिमेंट को एठी अछि मोर टोटल टा अछि सेट T एई भितर मु S रो एलिमेंट रखिले आ बाकी T रो किछि भी एलिमेंट अछन जोडा S रो एलिमेंट रो लेस भी होई पारंती, S रो एलिमेंट रो बिगर भी होई पारंती. बुझला कि नहीं? एबे से कोन कहउछि infimum of T. तो हमें एबे पिक करनवा लेट infimum of T is equal to L. By the definition, if L is my infimum, then each and every element of T is bigger than or equal to L. Each and every element of T is is greater or equal to L. तो हमें सेटा लिखिले L is less or equal to Y और X एठी हम को लिखबा X is belongs to T. तो एठी हमें T सेट रे एलिमेंट को Y रे रिप्रेजेंट करिवा. Each and every element of T is greater or equal to L where Y belongs to T. बुझिगला? Now S is subset or equal to T. So let X belongs to S. That implies X is also an element of T. Yes or no? And each and every element of T is bigger or equal to L. Am I एमति लिख परिबे कि नहीं? ताले X is हमें कोन लिख परिबा? is bigger than or equal to L. What is L? L is our infimum of T. L कौन? L is our infimum of T. ताले देखो এই जो x আমি পিক করছন্তি কোठी s রে x টা থিলা আরবিটারি তাহলে এই जो x টা আমি আরবিটারি পিক করতিলে এই जो আরবিটারি এলিমেন্টটা ইনফিমম টু বড় আছে তাহলে এই जो x উড়া কাহার এলিমেন্ট s র এলিমেন্ট তাহলে s র এলিমেন্ট সবু s র এলিমেন্ট উড়া ইনফিমম অফ t টু বড় তাহলে আমি যদি ইনফিমম অফ सेट S फाइंड आउट करिवा ए जो सेट S रे इनफिमम फाइंड आउट करिवा तले एठी कोठी आसीबो तले ए जो इनफिमम टा भी कोन हबो जदी सब एलिमेंट उडा इनफिमम ऑफ T रु बडो अछंती तले इनफिमम ऑफ S टा आइदर इनफिमम ऑफ T से तो इक्वल हबो नहले ताठू बडो हबो काहे कि ना X उडा तो ताठू बडो अछंती ना S रे एलिमेंट जदी बडो अछंती तार इनफिमम टा भी बडो हबो बुझिला कि नै क्लियर हे गेला वर्तमान स्टेटमेंट देखो आको रिलेट करके हम पाखरे सेही जो दीटा रिजल्ट को कंबाइन करके हमके एटी क्वेश्चन दिया हितला इफ S and T are two non-empty bounded subsets of real number then show that if S is subset or equal to T then implies infimum of T less or equal to infimum of S less or equal to supremum of S less or equal to supremum of T. तो लास्ट लेक्चर में एटा बुझितले if S is a subset of T then Then what is the relation between the supremum of S and supremum of T? This is look like this. Supremum of S is lesser equal to supremum of T. Then what is the condition when S is subset of T between the infimum of these two set? Infimum of S is bigger than infimum of T. Okay. Now, if S is any non-empty set, then if S is any non-empty set, then what is the relation between infimum and supremum? This is basically infimum of S is less or equal to supremum of S. Now combining these three statements, we get the required result. बुझिला ये लास्ट लेक्चर हम डिस्कशन करथिले एबे हमें जिबा तमानकु होमवर्क रे देइथिले जोडा हम सेटा टिके डिस्कशन कर दबा ठीक अछि देखो फास्ट हमको कोन दिया है क्वेश्चन हमको कोन कहै छी व्हिच ऑफ द फॉलोइंग सेट्स आर bounded above, bounded below, or otherwise. तामाने कौन जदि बाउंडेड सेट अच्छी बाउंडेड सेट भितर दीटा कैटेगरी आसी गला सो बाउंडेड सेट माने कौन बाउंडेड बिलो भी हेतिबो बाउंडेड बिलो भी हेतिबो सॉरी बाउंडेड एबव और बाउंडेड बिलो बोथ हेतिबो जेतोळे हमें अनबाउंडेड कथा कहबा अनबाउंडेड भितर कोन आसीबो आइदर अनबाउंडेड एबव और अनबाउंडेड बिलो और बोथ जदि ए तीनटा को होउची ताले अनबाउंडेड हे जिवे सेटटा बुझिले कि नै तो एठी हमको देखिया पय पड़िबो को सेटटा बाउंडेड अछि को सेटटा अनबाउंडेड अछि जदि बाउंडेड एबव होउची ताले तार सुप्रीमम कोन इनफिमम कोन बा एलयूबी और जीएलबी कोन ए सब को हमको फाइंड आउट करिया पय पड़िबो बुझिले कि नै क्लियर बर्तमान देखो गोटे गोटे हमें डिस्कशन करिवा तो फर्स्ट सेट हम कोन दिया अछि 1 बाय n एटा सब हमें डिस्कशन करि छथि बट हमें एबे किछटा ग्रुप ऑफ एग्जांपल का संगे नोट करि रखिवा तो सेति भाई हमें सब गुडा को गोटे सागरे कलेक्ट कर दबा ठीक अछि फर्स्ट क्वेश्चन कोन कहै छी फर्स्ट सेट अछि 1 बाय n तो जते बेले तुम पाखरे सेट थिबो तमे जेबे भी एग्जाम रे बसिके क्वेश्चन सॉल्व करतो फर्स्ट तुम देखो सेट कोन दै छी सेट रे एलिमेंट को टाइप रे अछंदी फर्स्ट सेट रे एलिमेंट को राइट करो लिखि दियो तापर तुम मानको सब प्रॉपर्टी गुडा देखा जिवो आगे बुझे लगे फर्स्ट सेट रे एलिमेंट को तुम चिन्हिबा जानो लिखिबा जानो तापर सेट को जदी पढिबा जानि गलो क्वेश्चन 50% सॉल्व हे जिवो बुझे लगे एबे देखो एटी हमको जो सेट दिया है सेट अछि 1 by n and n belongs to n ताले what is the element of this set this is basically if we put n is equal to n then get the first element like 1 if we put n is equal to 2 then we get the second element like 1 by 2 similarly we get 1 by 3 1 by 4 and so on the element of the set is look like this okay now is this set bounded above or bounded below or both or what is the behavior of the set okay देखो एटी कोन होची आमे जते बेले तमार मन रखियो जते आमे डिनोमिनेटर को बड़ करी करी जीवा समथिंग डिवाइडेड बाय डिनोमिनेटर और डिनोमिनेटर को आमे बड़ करी करी चल चंदी n टेंड्स टू इंफिनिटी बहुत बड़ बिगर नंबर नै जीवा तो से जो क्वांटिटी अछि से जो एक्सप्रेशन टा close to 0 है close to 0 एटी देखो 1 divided by something and something is bigger yeah, that means denominator is tends to infinity then what is the value of this expression this value is close to 0 this value is close to 0 but 0 is not belongs to this set okay okay clearly S is bounded because every element of this set is bounded by 0 and 1 but 0 is not an element of this set every element of this set we can write like this 0 no not like this 0 is not belongs to this set okay but 0 is supremum of this set what is the infimum sorry 0 is infimum of this set but 1 is the supremum of this set 1 is the biggest element okay so here the supremum of this set is equal to 1 and infimum is equal to 0 but infimum doesn't belongs to this set doesn't belong to this set because 0 is not an element of this set okay supremum is equal to 1 and 1 is belongs to this set implies 1 is the maximum element of this set but 0 is not the minimum element of the set एठी हमको पचारि थिलो ना smallest element and biggest element supremum infimum bounded above bounded below acha what is the behavior of the set this is basically bounded above but not this is both bounded above and bounded below that's why this is a bounded set okay The next example is minus 1 to the power n into 1 by n. Basically, the element of this set is like minus 1, 1 by 2, minus 3, minus 3, 1 by 4, minus 5, like this. Okay. If we write this set like this, minus 1, minus 3, minus 5, minus 7, union, sorry. This is not like this. This set is basically this set is basically minus 1, 1 by 2, minus 1 by 3, 1 by 4, minus 1 by 5, like this. This is the set. And we can write this set like minus 1, minus 1 by 3, minus 1 by 5, dot, 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 union 1 by 2, 1 by 4, 1 by 6, dot, dot, dot. We can write like this. If we take this union, then we get this set. Okay. Basically, here I write the set minus 1 to the power n, 1 by n. This is equal to 1 by n when n is equal to even, and minus 1 by n when n is equal to odd. This is the same set. This set and this set are same set. If we take the union, then we get the whole set. Okay. Here we can see this set and this set, both set are bounded, and union of bounded set is also bounded. Okay. Here the minimum element, when we take the denominator as tends to infinity, then the whole quantity goes to 0. Here also the same thing, when we take the denominator as a bigger number, bigger even number, then this quantity also goes to 0. Okay. This goes to 0, this goes to 0. But in the first set, which one is minimum element and which one is the biggest element? Here we see minus 1 is the smallest element and also belongs to this set. That's why this is a smallest element, and this is the infimum. This is the infimum. So the infimum of this set is basically minus 1. This is our infimum, and the supremum is 1 by 2, and 1 by 2 is here, and each and every element is less than 1 by 2 in this set, and each and every element of this set is smaller, is bigger than minus 1, is bigger than minus 1. So that's why this is the infimum and this is supremum, and infimum and supremum both are belongs to this set. That's why this is the smallest element and this is the biggest element, but 0 is not an element of that set. Okay, clear? Now minus 1 to the power n, basically this set is expressed like this. This is n when n is even. Okay, and minus n when n is odd. Clearly we see that this set is unbounded, because this is both unbounded above and unbounded below. Okay, and the next question is 1 plus minus 1 to the power n divided by 1 by n. The set is like this: 1 plus minus 1 to the power n into 1 by n. Okay, here we can write this set like this: 1 plus 1 by n and 1 minus 1 by n. 1 plus 1 by n when n is equal to even, and 1 minus 1 by n when n is equal to odd. Now collect the element of this set. When we put n is equal to 1, n is equal to 1 is n is an odd number. That's why here we take this expression and put n is equal to 1, then we get 1 minus 1 by 1, 1 minus 1 is equal to 0, then the first element is 0. And now we put n is equal to 2, 2 is an even number, that's why we take this expression 1 plus 1 by 2, and this is basically 3 by 2. The next we put n is equal to 3, then take this expression, because n is equal to 3, 3 is a odd number, that's why we take this expression 1 minus 1 by 3, then this is basically 2 by 3. Similarly, if we put n is equal to 4, then we take this expression, because n is even 4, and 1 plus 1 by 4, this is equal to 5 by 4. Similarly, we find the element of the set like this: 4 by 5, 7 by 6, 6 by 7, like this. Okay. So now, what is the behavior of the set? What is the behavior of the set? Okay. देखो एबे हमें कौन करिबा कलेक्ट ऑल दोज एलिमेंट whose denominator is bigger than the numerator. Collect all those element, basically collect all those element where n is even number here. Okay, to collect and make a group. This is basically okay, also take 0 also and then collect all those elements where n is even number. N, if n is equal to 2, no, if n is even, okay, first collect like this, collect all those number where n is even, and if you take not like this, okay, n, here the expression is basically n plus 1 by n, and here is n minus 1 by n. Okay. Okay. Okay, now collect like 0 by 1. This is basically 0 by 1, and next 2 by 3, and take this in this, next 4 by 5. This is n is equal to this, we get 0 when n is equal to 1, we get 2 by 3 when n is equal to 3, we get 4 by 5 when n is equal to 5, and so on. Next element, right, this is 3 by 2 and 5 by 4, and so on. Okay. Okay. uh Here we also we can write like this, continue ଏମିତି କରିବା, and here we can write 2n plus 1 divided by 2n, like this. Okay. Look here, if we put n is equal to 0, n is equal to 0, for n is equal to 0 this quantity is not defined. If we put, because n is belongs to natural number and 0 is not a natural number, then we put n is equal to 1, then here we get 3 by 2, n is equal to 2, then we get 5 by 4, n is equal to 3, then we get 7 by 6. Okay, and so on. And here the general term of this set is basically n 2n minus 2 divided by 2n minus 2. Here if we put n is equal to 0 and n is equal to 0, then here we get sorry, we cannot put n is equal to 0 because 0 is not an even number, sorry, 0 is not a natural number. And now if we put n is equal to 1, then this is basically 0 by 1, and similarly look like this. Basically this is the property of this element. Okay, 1 plus minus 1 to the power n divided by 1 by n. Here we can separate look like this, and now this set is break into these two set, like this and this. This is a set and this is a set. This is the, if you take the whole set, if you take the union of the whole set, then we get the complete set. Okay, now what is the next step here? Now 0 by 1, 2 by 3, 4 by 5 are increasing and tending towards 1. Okay, tending towards 1, whereas the improper fraction, like here are all the fraction are proper fraction. Okay, all are proper fraction, and here all are improper fraction. Improper fraction, because here the numerator is bigger than the denominator, and here is the denominator is bigger than the numerator. That's why this is the proper fraction and this is the state of improper fraction. And here here all the element is increasing and tending towards 1. Okay, and here all the element are decreasing and tending towards 1. Thus there exist two number 1 and 3 by 2, such that here is an element is 0 and this set tending towards 1. Here for this set the smallest element is 0 and the biggest element is 1, and if in this set the bigger element is 3 by 2. Okay, and the lowest element is 1. Okay, that's why all these element of the set is lies between 0 and 3 by 2. Okay, yes or no? All the element of this set lies between 0 and 1. Okay, and 0 is also an element of this set, 1 is also but 1 is not an element of this set. Okay, so 0 is an infimum, and 3 by 2 is supremum. Okay, and 0 and 3 by 2 both are element of this set. So the smallest element is 0 and the biggest element is 3 by 2. Clear? Next set is 4n plus 3 divided by n. First collect all those element of the set. This is basically, if we put n is equal to 1, then 7. If we put n is equal to 2, then this is basically 5 by 2. Okay, and if we put n is equal to 3, this is basically 12 plus 3, 15 divided by 3, this is basically 5. Then 4 whole 3 by 4, and continue like this. Okay, here all the element, okay, here the set is basically 4 plus 3 by n, like this now. This is basically 4n plus 3. This is basically 4n plus 3 divided by n. We can write like this: 4 plus 3 by n. If n goes to infinity, then this quantity goes to 0. If n goes to infinity or very large number, if n tending towards a very large number, then this quantity tends towards 0. Okay, so here is 4. If n is equal to 1, then we get 7. Then all the element of this set lies between 4 and 7. Okay, all. Okay, otherwise we can think like this. Here we can write this set like 4 plus 3 by n. The smallest element of a natural number is 1. If we put n is equal to 1, then we get 7. And the largest element we cannot find in the set of natural number. If n goes towards infinity, then the whole quantity goes towards 4. But 4 is not belongs to this set. So every element of this set, the given set, is lies between 4 and 7. Okay, 4 and 7. But 4 is not an element of that set. We cannot get 4 for any possible value of n. Okay, so infimum of this set is equal to 4, supremum is equal to 7, but 4 is not minimum element, but 7 is a maximum element. That's it, maximum element of that set. The next set is n divided by n plus 1. N divided by n plus 1, n divided by n plus 1, and the element of that set is equal to 1 by 2, 2 by 3, 3 by 4, and like this. Okay, here this same expression we can write like this: n plus 1 minus 1 divided by n plus 1, and this is basically write like this: 1 minus 1 by n plus 1, and the first element of the natural number is 1. 1 minus 1 by 2. This is basically 1 by 2. And the largest element of set n, we cannot get the largest element of set n. So if we take n tends towards infinity or very large number, then this whole quantity goes towards 1. So all the element of this set lies between 1 by 2 and 1. But we never get 1. 1 is not element. 1 is not an element of this set. So but 1 by 2 is an element of that set. So 1 by 2 include होगा. 1 by 2 का मैं include करीबा. 1 by 2 is less or equal to x less than 1. So 1 by 2 is infimum and minimum element, because 1 by 2 is an element of that set, but 1 is supremum but not maximum element. Okay, similarly ये जो सेट हम पाखे रहिला -2 -3 by 2 -4 by 3 -5 by 4 like this. तो ये जो सेट रहिला ये सेट ऊपर हमें कौन कमेंट कर परिबा हमें देखि पारुछे एटी -2 अछि. ओके, ये जो हम पाखे देखो जनरल टर्म दिया है, द जनरल टर्म इज लाइक n plus 1 minus n plus 1 divided by n. This set can be this general term also written like this: minus 1 minus 1 by n, like this. If we put n is equal to 1, then here we get -2. If we put n is equal to 2, then -3 by 2. If we take n tending towards infinity, then the whole quantity goes to -1. all the element of this set lies between -2 and 1, and -2 is very small number and -1 is bigger number. So -1 is the supremum of the set and -2 is infimum of this set. -2 is an element of this set, that's why this is a minimum element, but -1 is not an element of these sets, that's why this is only supremum but not maximum of this set. Okay, the next one is 1 comma 1 plus 1 by 2, 1 plus 1 by 2 plus 1 by 2 square plus dot 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 1 plus 1 by 2 plus 1 by 2 square plus dot 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 plus 1 by 2 to the power n minus 1 and so on. Then what is the supremum and infimum of this set? Okay, the first element of this set is basically 1, then 3 by 2. Okay, not like this. Here 1 plus 1 by 2, and what is the sum? Basically this is a this is in GP, geometric progression, and what is the sum of this expression? This sum is basically written like this: 1 minus 1 by 2 to the power n divided by 1 minus 1 by 2. If we solve this expression, then finally we get 2 minus 1 by 2 to the power n minus 1. If we put n is equal to 1, then the whole quantity is 1, is n minus 1, n minus 1, and if we put n is equal to 1, then 1 minus 1 0, 2 to the power 0 1, 1 by 1 1, 2 minus 1 is equal to 1. Here we get n is equal to 1. The first element is 1. Okay, similarly we get all these elements. Sum of this element, here is 1 plus 1 by 2, here is 1 plus 1 by 2 plus 1 by 2 square. Accordingly, if you put n is equal to 2, then get this quantity, n is equal to 3, then get this quantity. Okay, if you take n tending towards infinity, then the whole quantity goes towards 2. Okay, goes towards 2. That's why the element of this set lies between 1 and 2. Okay, 1 and 2, but 1 is an element of this set, but 2 is not an element of this set. Okay, 1 is infimum, 2 is supremum, 1 is minimum element because 1 is an element of that set, but 2 is only supremum but not maximum of this set. Now the set of real number, is an unbounded set. Okay, set of a real number is an unbounded set. Clear? Next example, if A and B are bounded subsets of real number, then prove that A intersection B and A union B are also bounded. Basically, if we have two bounded sets, then their intersection and union also bounded. Here we have to prove that the union and intersection of two bounded set is also bounded. Okay. Okay. How to prove? Mathematically, right? Prove. Since A is bounded, right? Since A is bounded, there exist two real number. There exist two real number. There exist two real number L1 and K1 such that L1 is less or equal to element of X and less or equal to K1. Okay, if a set is bounded, then this is both bounded above and bounded below. This side, the definition of bounded below set, and this side is the definition of bounded above set. And if we write combining, if we combining these two statements, then we can write like this: L1 is the smaller than all the element of set A, and all the element of set A is smaller than K1. Okay, all the element of A is bigger than L1 and all the element of A is smaller than K1, and that's why A is the bounded set. Okay, for all X belongs to set A. Similarly, we can write for set B, let there are two real number L2 and K2 such that L2 is less or equal to Y and less or equal to K2 for all element Y belongs to B. Okay, now take the minimum of L1 and L2. Now take the minimum of L1 and L2 and denote it by L. Let L is the minimum of L1 and L2 and take the maximum of K1 and K2 and naming it by K. Let K is the maximum of K1 and K2. Okay. Now we take the intersection A intersection B. Okay. Then, okay. Now, okay. Therefore, L less or equal to P less or equal to K. Okay. For all P belongs to A intersection B. Here we take the minimum of L1 and L2, maximum of K1 and K2. That's why all the element of A intersection B is lies between L and K. Yes or no? Graphically, let this is our A set and this is our B set. Okay. This is A set and this is B set. And this part is our A intersection B. Okay. Now let this one is L1 and this one is K1 and this one is L2 and this one is our K2. Here we take the minimum of L1 and L2. This one and this one. We take the minimum. Maybe this L2 is here. Maybe. Or maybe L2 is here. Maybe L2 is coincide with L1. So in this side we take the minimum. Okay. And for maximum, here we take the lower bound, and for the upper bound we take the maximum of K1 and K2. Maybe K1 is here or coincide or here. Anything. K1 is either here or here or here or here. That's why we take the maximum of K1. If we take the minimum of L1, then all the element of A and B lies between L and K, because L is minimum of L1 and L2. So every element of A is bigger than bigger than L. All the element of A is bigger than all the element of A set is bigger than this L. Also, all the element of set B is bigger than L. Similarly, all the element of A is smaller than K. All the element of B is also smaller than B. Smaller than this K. Okay. All the element of A is bigger than this L. All the element of A is less than this K. All the element of B is bigger than L and all the element of B is smaller than K. If you take the common element of A and B, this also lies between this L and K. That's why L is smaller than all the element of P and all the element of A intersection B and all the element of A intersection B is less than K. Okay. That's why A intersection B is also bounded. Okay. Similarly, if you take P belongs to A union B, the same things can be right. That's why A union B is also bounded set. Okay. So ethi mone rakhibar jinsa kon, the main thing is to remember here, we take the minimum of L1 and L2 and maximum of K1 and K2. Okay. The next question is, if S and T are arbitrary, non-empty bounded subsets of real numbers, then show that the supremum of S union T is equal to maximum of supremum of S and supremum of T, and infimum of S union T is equal to minimum of infimum of S and infimum of T. How to prove this thing? Okay. Here we have to show that the supremum of S union T is equal to maximum of supremum of S and supremum of T. Okay. Let the supremum of S is equal to small s and the supremum of set T is equal to small t. Okay. Now here we have to show that the supremum of S union T is basically the maximum of S comma T. Okay. Let X be an arbitrary element. Let X be an arbitrary element. Let X be an arbitrary element of S union T. S union T. Therefore, X is an element of S or X is an element of T. That's why X is an element, because because this X is an element of S union T. That's why we can write S is an element of S or X is an element of T. Okay. Then we can write X is smaller than the supremum of S. Also, we can write X is smaller than the supremum of T. Okay. Because X is an arbitrary element and every element of a set is smaller than its supremum. That's why you can write these two statements. Okay. Now, here we can write X is less or equal to T because T is supremum of S, or X is less or equal to, here supremum of S is equal to small s and supremum of set T is equal to small t. Okay, X is less than S, X is less than T. That's why X is also less than the maximum of S and T. Okay. Here is a word is or. Either X is less than S or X is less than T. So combiningly we can write like this. Okay. देखो, if X is less than 5 and X is less than 7, or here is or. देन आम ये कौन पिक कले बोथ स्टेटमेंट को से एडजस्ट कर परियो जदि आमे x इज लेस देन 5 नबा जदि हमर x 6 हे जिवो तले हमर कॉन्ट्राडिक्शन आसी जिवो बुझले कि नै तो सेति भाई हम एटी मैक्सिमम नै जिवा जदि हम पाखरे x एटी आस्तांदा एंड एटी जदि एंड आस्तांदा एंड बेडू हम कोन करथांदे बोथ स्टेटमेंट को सैटिस्फाई करला बेले गोटे नंबर पिक करथांदे जदि एंड हेइथांदा एंड बेडू हम एटी कोन करबा जदि हम लिखि देउछे x एटी जदि हम मैक्सिमम नै जिवा आ मैक्सिमम नै गले जदि हम 7 नै जिवा तले आकु कॉन्ट्राडिक्ट करि जिवो बुझला कि नै तो सेति पई और आउ एंड को भल से त माने मार्क करिवो मु जोटा कहिले का आउथर रिपीट करूची इफ x इज लेस देन 7 एंड x इज लेस देन 10 हियर इज और and one then the other case is end. If the first case is or, then what is the best answer for us? Here we take the maximum of 7 and 10. If we take x is less than 10, then this satisfy both the statement this and this. Okay, if the other statement is end, if x is less than 7 and x is less than 10, here is end, the conjunction is end, then if we take x is smaller than 10 and here is the here is one option is end. If someone takes x is equal to let's say 9, then the first statement is false statement because 9 is not less or equal to 7. That's why if the conjunction is end, then in that situation we take the minimum of these two numbers 7 and 10. Then the minimum is 7. If someone takes 6, then this satisfy both the statement. Okay, the other statement is infimum of S union T is minimum of infimum of S and infimum of T. Here is minimum. And how to deal this statement? तो ये जो केस 2 अच्छे केस 2 तुम निजे ट्राई करो करिया पे आराम से करि परियो कि असुविधा नहीं हमको एठी इनफिमम फाइंड आउट करिया पे अछि बुझला कि नहीं now here we get maximum of S and T. X is less than maximum of S and T for all x belongs to S union T. Okay, now maximum of S comma T This is basically maximum of supremum of set S and infimum of set sorry, supremum of set S and supremum of set T. Okay, will be the supremum of S if we show that no real number less than maximum of S and T can be an upper bound of S union T, and K be any real number less than maximum of S and T. देखो आपर हमको देखिया पई पड़िबो कि आउ कोनोसी नंबर आसीबोनी जोटा कि सुप्रीमम हे परिबो कि इनफिमम हे परिबो। एठी बेसिकली हमको कोन देइतला सुप्रीमम ऑफ एस यूनियन टी ना, तो एठी हमको पुनी दुईटा केस रे डिवाइड करे पई पड़िबो। तो हमको एबे कोन देखिया पई पड़िबो, now maximum of st will be the supremum of s if we show that no real number less than the maximum of st can be a upper bound of s यूनियन टी कहीं आम जो सुप्रीमम डेफिनेशन पढ़ी से डेफिनेशन कही कि नहीं कि जदि आम क्लेम कर अल्फा को सुप्रीमम अल्फा टू किसी आम माइनस करदे से भी अपर बाउंड हबनी। तो से जो स्टेटमेंट थिला से स्टेटमेंट को हमको प्रूव करने पड़ो। नाउ let k be any real number. Now let k belongs to r be any real number less than the maximum of s and t. Maximum of s and t, that means that implies k is less than s or k is less than t. K is less than t. Accordingly two situation arises as discussed here. Case 1. Now let k is less than s. First case, k is less than s. That means k is less than supremum of s. Then by the definition, k cannot be an upper bound of s because the k is smaller than the supremum of s. That's why k is not an upper bound. Implies therefore sum x belongs to s such that x is bigger than k. X is bigger than k. Therefore sum x belongs to s such that x is bigger than k. Implies therefore sum x belongs to s union t such that x is bigger than k. As x belongs to s, that implies x belongs to s union t. जदि x टा s रे अछि तले s यूनियन t रे भी आसीबो। implies हमें एटी कोन पिक कले कि k टू बिगर हमें गोटे एलिमेंट पिक कले कोठी s सेट रे। जदि k टू बिगर अछि s सेट रे x तले एई x टा कोठी आसीबो s यूनियन t रे आसी जिवो। यस और नो? ओके, implies k is not an upper bound. K is not an upper bound of S union T. Okay. Why not upper bound? Here the upper bound is S and K is less than S. So K is not an upper bound of S union T. बुझे कि नहीं? Thus we see that the maximum of st is an upper bound of s union t, and no real number less than the maximum of st is an upper bound of s union t. Hence by the definition supremum of s union t is equal to maximum of small s and small t, basically supremum of s and supremum of t. And similarly we can prove that the second result, the infimum of s union t is equal to the minimum of infimum of s and infimum of t. This is your task. You have to complete this task. Okay, and this is your homework. Try to solve all this question. Okay. तो आज लेक्चर एति। नेक्स्ट लेक्चर हमें बहुत सारा नुआ डिफरेंट थ्योरम देखिबा, बहुत सारा वेल नोन प्रॉपर्टीज अच्छे जेमिति का हमर कंप्लीटनेस प्रॉपर्टी ए सब जिंस हमें नेक्स्ट लेक्चर डिस्कशन करिबा। ओके, जो माने आराम से शेष पर्यंत लेक्चर देखिलनी समस्त को थैंक यू। जदि तुम ए लेक्चर किसी शिक्षा पाउछ, बहुत सारा जिंस हमें कंप्लीट डिटेल डिस्कशन करूछंदी जोडा तुम मानको आउ कोठी अदर वे रे मिलिबोनी। ठीक अच्छे, जदि तुमको लेक्चर भल लगुच तो लेक्चर गोटे लाइक करिवो, चैनल को सब्सक्राइब कर रखिथो, निज सांग मान भितर शेयर करनवा।